All right, so we're in day 2 of digital learning, and we're in unit 4, which is about exponential functions. So today we're going to talk about some different parts of the graph and what that looks like. So first, here's the formula for an exponential function, or what the equation looks like. I like to think about it as a standard form. Kind of like in quadratic and linear, we have a standard form for quadratic and standard form for linear. This is standard form for exponential, a times b to the x. And we said yesterday in exponential functions, we're used to the exponent. We know what that is, but in this unit, the exponent is going to be a variable. All right. So today we're only going to focus on one part of this equation, which is just b to the x. And what b tells us in an equation, b tells us, is this going to be growth or decay? So is this growth or decay? Think about these two words. Growth means going up, increasing. Decay means going down, decreasing. So this number here is going to tell us if it's growth or decay. So let's do a little example here. Well, first, let me show you the graph, all right, of what that looks like. All right, so on a graph, growth looks like this, going up from left to right. This is growth. This red line is going up from left to right, okay? And then this blue line is going down from left to right. We call that decay, all right? But in an equation, y equals a times b to the x, or I should just say b to the x right now, that number right next to the exponent tells us if it's growth or decay. If it is greater than 1, like y equals 2 to the x, that is growth. Or y equals 3 to the x, or y equals 15 to the x. All that is growth, is greater than 1. But if it is between 0 and 1, like y equals 1/2 to the x, or y equals 0.3 to the x, or y equals 2/3 to the x, all that is decay. That means it's going down from left to right, okay? So greater than 1 is going up from left to right, is growth, all of this, and less than 1, between 0 and 1, is going down, okay? So on a graph, you can have, we said this is growth, going up from left to right. Put a G for growth. This is decay, going down from left to right. But guess what? You can also have the reflection of growth and decay. All right. So if I reflect this over the x-axis, I end up with this. And it looks like decay, but guess what? This is still growth. And if I reflect decay over the x-axis, it looks like this. And this is kind of tricky because it looks like growth, but it's really still decay. So I have growth going up from left to right, and decay going down from left to right. But I can have the reflection of these two, and it's still growth, it's still decay. All right. So you may want to screenshot that. All right. So let's see if you can get these. All right. Is it growth or decay? So you might want to pause the video, get all the answers, and then see if you got it right. So go ahead and pause the video. All right. So welcome back. Hope you got all the answers. So the first one is decay, going down from left to right. The second one is growth, going up from left to right. The third one is decay, going down from left to right. All right, down. The fourth one is decay, going down from left to right. The fifth one is growth, is going up from left to right. And the last one is also growth, going up from left to right. All right, awesome. Okay, so last thing you're going to learn today is about the word asymptote. This is a new vocabulary word. I know it sounds like a curse word, but it's not. Trust me. Asymptote. The asymptote is a line that the curve approaches but never crosses. So in this unit, our graph looks like a curve almost. But that is because we have this thing called an asymptote. It's kind of like a fence, all right? It's a fence that keeps the graph from going any further, all right? It approaches it, but never crosses it. I like to think about it if you have a dog or a puppy, all right? See if I can draw one. Okay, so if your dog is not on a leash, a lot of times it'll just run as far as it can run, all right? But you might want to invest in a fence. So I think about the dog who sees another dog cross the other side of the fence, all right? And it tries to run and play or bark at the dog, all right? But it goes, but then it hits the fence and it can't go any further. And all it can do is just run along the fence and bark at the dog. All right, so our fence keeps our graph from going any further, and it's called an asymptote. So our job is to tell where the asymptote is on the graph. So in this case, our asymptote, this invisible line here, and I'll put the line on here so you can see it right now, but we're going to take it away in a second. This dashed line is our asymptote, and it crosses at 1, 2, 3, 4, y equals 4. All right, so when they ask for the asymptote, just look for that line where the graph starts to get horizontal, and that's your asymptote, y equals 4 for this one. All right, look at this one. We can see it really clearly. The dashed line is at y equals -1, okay? You can see that your graph is going up, 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 and then it starts to get horizontal right here. That's the fence, that horizontal line. Where is it? It's at -1, okay? Now, this 0 is a little off here. It's supposed to be right here, so don't let that confuse you. It's still -1. All right, what about this one? Where are we crossing? Where's that horizontal line? 1, 2, 3. So y equals 3 is our asymptote, okay? Let's do another one, all right? Where is the asymptote? Where's that line that the graph starts to where it hits the fence? It's at y equals -5, the invisible fence, okay? All right, now we're going to take it away. We don't have the dashed line anymore to help us, but we can still see it. Where does the graph start to flatten out? All right, where's that on the y-axis? It is at 0. So y equals 0 is the asymptote, okay? Even though we can't see it, it's there at where the line starts to get horizontal, where the dog starts to run along the fence. All right, that's your asymptote. Okay, what about here? It's pretty easy to see. Okay, where's the fence? Where's the dog running along the fence? If I follow the line right there, so that's at 3. Y equals 3 is the asymptote. All right, what about this one? There it is, that horizontal line, the fence that the dog is running along. Y equals -6. That's the asymptote. I think we got one more. All right. Horizontal line that is crossing or approaching is y equals 1. All right. So that's it. Okay. Check the website